Greetings, this is Phi, 21.171, and this is a follow-on to my previous video on the Mutation Explorer. It's right here. A tool for analyzing simple graphs and running the mutation game on it. So today I want to do a little code review. I didn't do it the last time, but not very in-depth, but just enough so that if someone was interested in taking a look at it, they would be able to get started. And so anyway, let's go in here. What I want to do is remind you of the Github repository. So here we have all of the code, and you can clone this or fork it and create your own development. I would love to have others contribute to this. And so one of the things that I've done is started adding some issues for further enhancements to this. So if you remember from last time, it's really kind of simplistic as far as what the functionality of the tool is doing right now. I've started thinking about some other things. Number one, updating the graph definitions, providing more graph definitions, and maybe rethinking the organization of them and how the nodes are organized, for instance. Then refactoring the code into modules, and I'm a little bit on the fence on this. One of my decisions from the beginning with this project was to make it as simple as possible. I like working with JavaScript modules, but they unfortunately can be a little more challenging because they require you hosting the web page from an HTTP server in order to work properly. So that would make it a little bit more difficult, but something to consider. Determining the unique root populations. So from this table here, identifying all the unique sets of values for unique populations, which is a set of values at a particular point in time, and do some statistics and look at coverage on that and see if we are able to touch all of the possible root populations through the algorithm that we're using with the mutation game. And let's see, what else? Interactive play. So you may have noticed that when I did the demo the last time, that I was able to click on these and stuff, and right now they're not doing anything, but my anticipation was actually being able to decide which node you would want to mutate, and it would perform the mutation operation and add the values to the list. Right now everything's really simplistic. When I hit the run button, it clears out all previous instances and does a new run from the beginning. So I hope to add that. I think that that's an important thing, and it could actually turn it into a game. You could set certain kinds of goals for different kinds of graphs to see, like, especially if you're playing with somebody else, like, can you force someone to go above a certain population value or whatever. So there could actually be some fun little game-like logic things to do with this. Let's see, we'll go back to issues, and then provide alternate run modes. Somebody on the forum suggested, a greedy mode. There might be other things rather than round robin, bouncing back and forth, or trying some different approaches to see what might happen. And the greedy mode kind of anticipates that you'd have some kind of statistical analysis or some kind of awareness of which node might bring you to a higher population value and stuff, but I'm not really quite sure about all the implications of that here right now, but it's something to think about. So anyway, I want to come back to the code here. We'll go back to this tab, and so if you were to clone the GitHub repository, you would get a folder full of files like this. It's actually pretty straightforward. Right now there's just a simple index.html file. And I'll also remind you to come back to GitHub, that if you click this link here, this particular instance of code is being hosted on GitHub through their pages, so you can click on this and run the application yourself and play around with it. So yeah, so let's go back to the code. So this is all really about the structure, logic, and style of a particular idea, right? And so we're creating this game. The structure is the HTML, and in this case, it's really quite simple. Oops. Okay, so we have our HTML page. Shift-E opens it in Vim, and in here you can see I've got a fairly simple head. There's a number of small JavaScript files. I tend to like to partition things, and they're starting to become a number of them, and they're becoming library-like. So this is where I want to start maybe shifting things into modular structure here. But from there, you can see that we've got just a simple head. The nav element holds all of the UI controls, and the main section holds the 4 panels that show the graph and the plot and the table and the definition over here. Really pretty straightforward. As far as the JavaScript, we load the d3.js library here at the beginning. Then I load the graph definitions, the mutation functions, then the 4 tools for rendering the data on the screen. And the final one is the main function, which also has the defer attribute on it, so it gets run last. So it won't get run until all of the other code elements are in place. But before we jump into the code, I just want to mention, you'll notice that there's no style information in here. All of that's being driven from index.css. And let's see, we'll jump into that. And again, it kind of parallels the HTML structure. So, I recommend you take a close look at this. I am starting to do some responsive stuff. It's not quite working right now. I've got to rethink it, but I am using grid for the layout and flex in a couple places, as well, I think. All right. So all pretty straightforward, and, recommend that you take a look at that as well. So let's close this one. And yeah, let's jump over to some of the code. So I'm going to close this out, and the index.js is here in the root directory. And let's open that. And so we have a main function. It starts by setting the neighbors on the current graph. So the graph definition, maybe I should start with the graph definitions here. So yeah, graphs. Okay, so all of the graphs are contained in a JavaScript object. As you can see, they're named here, and then inside the brackets, we have both the set of vertices and the set of edges that are necessary to render the graph. And pretty simple. I've started playing around with some of these, as I mentioned in the last video. So like with D4, for instance, you can see the 4 nodes, but in this one, I changed the position of the 0, so you can see the 0 is out on a branch, and here the 0 is in the center and is branching to all of the other elements. And then D4 tilde, I fixed the tilde thing. I just needed to quote the name there in the definition. And oh, in fact, I think this, I should do that here too. I'll do that right now. You get to see me do it. So let's see, S tilde this, and I think we'll change this down here. So now tilde should appear in the graph definition. Okay, so anyway, I think this is pretty simple JavaScript, stuff, and I take this entire definition of graphs and I use it as a list, and I populate the drop down with it. So it's really kind of important. But you'll notice that while the edges define the relationships, if I were to run the mutation game, I would have to go through and query that list to find all the relationships, for all of the neighbors from a particular node. So I do that all up front, and then I place those into a neighbors list that is a part of the graph object. And so that way for each node, that is, I do that. And each node will also have a value attribute. And so we'll take a look at that in a moment over here. But the graph definition, that's the important starting point. Oh, I'm going to save that. That's right. Okay. All right. And then I do some UI instantiation, so all of the UI selectors and drop-downs and things are being instantiated here, and then we call the run function. Run grabs the current graph from the drop-down definition that's being set, and then initializes all the values in each of the nodes in the graph, then clears the population and sets an initial population. Then next we instantiate a new graph object. This is part of the tools library, which I'll jump into in a moment. Then we also get the current value for the modes and the number of cycles, and then we just have a little for loop that runs through and for as many cycles as we've defined, and then based on the mode makes a determination on which function to call. So I have a random function, or here I just go round robin based on the index from this for loop using a modulus bounded by the number of keys in the graph. And pretty straightforward. So the S function is actually what performs the mutation here. So we get that next key and we pass it in as a value. And then once we've collected all of our data, we've populated the population array, we then dump that into the table on the screen and then plot the values onto the plot. And this could have been done earlier, but I show the code for the graph definition in the lower corner. So each of these, pretty straightforward. There's not much that really happens. But in the other tools, in the tools folder, let's see, I'm going to jump out of this here right now. I'll go in here under JS, under tools. These four JS files are instantiated by the code. I pass the parent ID from the HTML in there, and then it does all of the D3 operations to translate the data into the visual elements on the screen. So graph is probably the more complicated one, but we'll take a look at that here right now. And so the parent ID is passed in. I instantiate an instance of the graph here. I use D3 as my selector to get the element so that it can perform operations on it. I call inner HTML and clear it out to... Okay, let's try that again. All right, so, and then, get some width and height and, other margin kinds of, things that are set up for the graph so that it fits nicely in the space that we have for it. We create an SVG object, and then the rest of it is, kind of parsing the data and, creating the lines, creating the circles for the nodes here, and then a text object that labels the nodes. And then here, this is the real cool part, the force simulation. So I should have probably brought this up a little bit earlier, but let me jump into here and go to my D3 page. All right, so I brought this up the last time. If you're not familiar with D3, you ought to really take a look at the examples that are in here. It is, just such a tremendous example of what you can do when you have standardized your data, when you start to work in a more consistent form in the organization of the information that you have. Because when you manage that, then you have the ability to push that data through so many different sieves, so many different renderings, so many different, ideas. And, JavaScript kind of makes that easy because of the, kind of pretty cool, arrays and objects and different aspects of things that we have there. And then to be able to tie that very, very easily into the visualization environment of the browser is really cool. The gallery, if you go to examples and go to the gallery here, let's go to the top. Let's see. There are a couple that really stand out, and I think here under hierarchies, these trees, I think there's things I'm going to be wanting to do with them here in the near future. But the network graphs, and particularly the force-directed graphs, are really kind of amazing. So this is an example of a force-directed graph. This is all of the relationships from the novel Les Miserables. So you can see here this major node in the center is Valjean. And what's amazing is how this graph can be so fluid and can reorganize itself, based on, various forces that are being applied. It's really, really kind of amazing. And, all the code for this example sits in here. If you wanted to look at the data and how that's organized, we have an object that has an array of nodes, an array of links, very similar to our vertexes and edges. And, we have an object for each of the characters and objects for their relationships, right? So an important consideration that's not in the graph definition that we have is that both source and target need to be a named value for D3 in order to understand the links. So coming back to my code, you'll see there's I do a bit of translation on that somewhere, and I can't remember now where I do that. All right, well, anyway, I kind of clean up the data and make that easy for the graph to understand here. And there are so many different settings in this particular API for the force simulation, and you can really kind of control how the layout happens and stuff. I've tried to keep things as simple as possible for this version. What's more important is that the game run, not that it look so incredibly cool, but the coolness is definitely a factor. I definitely want to add this drag capability in here because I want to play with it. This ability to drag these nodes around. It's actually pretty simple. It's a few lines of code to be able to do it. So that'll come up in a future element. And this one, the dot plot. So this is where the example that I used to get the population summaries loaded onto the screen, and this is a much more sophisticated kind of graph, but I want to head in this direction. I think that each of the values of the nodes could be plotted, very similar to it. We have multiple values on each line here, so you can imagine a sum value and then each of the elements, and that way you'd start to see when there are positive and negative, elements on either side of, the sum, that may be, collapsing it down to a median or something. Anyway, but, this one is also very interactive. And that's one of the things about D3 that I really like, is that the ability to have the graphs be automatically updated as the data changes. And of course, as I said, I'm not doing that right now. I'm clearing everything out. But the next steps will be to, actually enable, things to be changed, reordered, filtered, all of that. I think it could be, very useful. So, I just wanted to give a quick, overview on the project, and I really encourage you to kind of walk through this on your own, and play around with it. And don't forget, like another great way to get to learn something is, Control-Shift-I, at least in Firefox. I'm not sure if it's the same anymore in Google Chrome. I haven't played that, but this brings up the inner HTML, and you can start to look at what's going on with respect to the screen. You can see each of our divs that's holding the elements, and then we have a graph. The SVG is sitting in there, and then there's kind of the inner graph, and then the collections of the nodes, the edges, the vertices, and the labels. You can see the edges are a collection of lines. Each of them are in position here, and the vertices. One of the really cool things, see if I can get it to work, is watch the values. So the force direction simulation, goes through this iterative process to figure out where all the nodes should be placed so that they are, within the proper constraints from one another. And I think that that's all pretty cool. It's fun to watch. Anyway, So I think I'm going to, let's see. We'll call it there. So I think I'll follow up again another couple of days when I've started to address some of the new features that I mentioned in the GitHub issues, and we'll go from there. Thanks a lot.